And then let me start up the closed captioning. I wish it would just stay on. So where is it? Live or? No, that's the wrong button. Live transcript, there it is. Okay. So if I click here, I should be able to show the subtitles. Okay, so I can see the subtitles now. Everybody else can too, if you enable them. Good, we're set to go. So a few announcements first. First, I'm very happy to see you all here. How many of you are here? Oh, all the best students in the class are here. Yeah, good. So you have a reading due tonight. No, tonight? Today's the 11th. Nope, chapter 5 is due on the 16th. Never mind what I said. So you have a chapter 5 is due on the 16th. And with regards to the readings, if you're at all unsatisfied or dissatisfied, I should say, with your reading grades, please feel free to go ahead and read more, do more of the books. General Amnesty, I'll grade again on the 16th. Okay? Or after the 16th. So if you missed a reading, please go ahead and do it, and I'll record the highest grade you've got. Second, you have a project due on the 15th. And that would be project 3. So with those announcements made, you have questions on Python, on the book, or a project?
I have a question from the book.
Go ahead.
Challenge activity 5.8.2.
Okay. Zybuk, not here. Okay. And it was challenge, say it again?
Challenge activity, and it's 5.8.2.
Okay. I'm looking forward to it. 5.8.
Yeah, and it'll be all the way at the bottom.
2. Okay. So the subject of this challenge activity, or this chapter, is, now you are all, I guarantee you, experts in nested loops, because you all have seen nested loops in action. If you've ever driven in a car, for example, even a clock, a digital clock is an example of a nested loop. What do I mean? Well, let's say the odometer in a car has perhaps tenths of miles, and that spins fast compared to the ones digit, which spins not quite as fast as the tenths if you have one. And then the tens digit doesn't spin as fast as the ones. And in fact, the ones digit is a loop, right? It goes from 0 to 9 back to 0, back up to 9, back to 0, up to 9, back to 0. And each time the innermost loop, the ones digit, let's forget about the tenths, each time the innermost loop loops around, that causes one tick in the loop, the next larger loop, in this case, the tens digit. And then the tens digit is itself a loop. It goes 0 to 9, back to 0, to 9, back to 0. Each time it ticks over from 9 back to 0, it causes the next outer loop to tick over once. So you have this idea of loops nested within other loops. And you also have this idea that the innermost loop is like faster than the next outermost, which is not quite as fast, which is faster than the next outermost, which is faster than the next outermost. So you have this idea of nested loops. So how about the concept? The concept of a nested loop, anybody? Okay, so something else that I'd like to talk about nested loops. We've mentioned like complexity, big O, performance measures, and let's consider what happens to performance when you use a nested loop. Okay, let me switch over to the iPad. I was just erasing. Okay, so if you have a loop like this, or let's say row in range 24, how many times is that going to execute?
24 times.
Good, good. So, and in fact, you could make a general statement that the number of times that this executes grows linearly with the number that's here. So if I had 48, it would execute twice as long than 24. But let's throw in a nested loop for column in range of 80. Then you've got some code here. Now, how many times is this going to execute?
80 times 24 times.
Yes, so the total number of executions is going to be this number times this number. So the growth in work is no longer linear, right? The growth in the amount of work now can grow exponentially because you have one loop inside another loop. So this would be called order, that's not going to stay on screen, order n squared. So an algorithm that, any algorithm that uses a loop within inside of a loop is already an order of n squared algorithm, which means that the work will grow exponentially depending upon the values of these two numbers. Okay, so let's get back with that background. Let's go to the challenge activity. Interrupt me if you have some questions. All right. So given num rows and num cols, oh, look at that. Print a list of all the seats in a theater. The rows are numbered, but the columns are littered. Let's see, num columns. Are they going to promise that we don't exceed the number of letters? I suppose they must. Okay, let's assume they do. Okay, so note number one, you'll need to declare some more variables. Note number two, place end equals at the end of your print statement to separate the seats by spaces. Okay, I got it. So which one's going to be the outer loop and which one's going to be the inner loop? In other words, row or column?
Rows would be the outer loop.
Correct. And how do you know?
Is it just because it's first in the output?
Okay, good. Well, tip off is you have the row is the same as the row is the same as the row. So that's changing very slowly. But look at the column, which is the letter. Change, 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 right? So the column is the inner loop, and it's changing, quote, faster. So the outer loop, that was important to answer because we need to know which loop to handle first. So for row number in range num rows, and that, why don't we, I'm just wondering to myself how we should take care of starting at 1 rather than starting at 0, because the one I've just written will start at 0. So we can handle it now or later. Pick one, anybody. Later?
Let's handle it now.
Let's handle it now. Okay, good one. So now means let's change the range to start at number 1 instead of 0, but that means we have to extend this by 1. Okay. All right. Now, the next one is going to be letters, which is a little harder. So for column number in range, and for this one, we're starting, trust me on this one, let's just start at 0 and go to num calls. Okay. So the column number is the inner, but of course it's not a letter yet. We'll have to turn it into a letter. I wonder how. So print, and we don't want spaces between the number and the letter. So let's use formatting. So here's where the number will go, and then immediately after it will be where the letter goes. And then we'll do what they say, end equals that. But let's go and finish. Now dot format. And it seems to me we could use row number right away. Row number. But then we need some way of turning a number into a letter. So we have call, let's see if we can figure this out. Call number. What if, so we're starting out at 0. What if we were able to add 0 to the letter A? Does that make intuitive sense? So we add 1 to the letter A, we get the letter B. In fact, that's how it works. So we have a column number, but the letter A isn't exactly, I mean, it's a letter. It's not a number. So I got to turn some way of turning the letter A into a number. And I'm reaching deep back into my memory. Is it ORD? Did they talk about that?
Yeah, they talk about all the way at the top of the chapter. They just touch on it briefly, but don't really go into depth.
Okay, so the ordinal of the letter A plus a number of the column number. And let's turn that into a string. And, oh, is this is that supposed to be, yeah, okay. So let's try this. Oops. Okay, so how about CHR? Is that a thing? That's a thing. Okay, let's break this apart. So call number goes from 0 to the number of calls minus 1. Okay, and it's a number, obviously. So A plus 0 is A, and A plus 1 is B. So that's what I'm after. However, I have to make the types work out correctly. So ORD of a letter gives you the binary, the uh, computer code equivalent of the letter. Okay. So in order to add a number to a letter, like I'm doing 2 lines above, A plus 0, they both have to be numbers. So the rest of the story here is ORD A is the number representing the letter A plus the call number is then made back into a letter using CHR. Okay, so there's the full explanation of that monkey business. So there's 2 questions here I have to ask you. First, how are you doing on the notion of the nested loop?
Yeah, I understood the nested loop. I was just having trouble getting it to a letter and getting that figured out. So I got the nested loop, just converting it using the ORD and CHR.
Okay, so now let's expand to the rest of the class. How are you doing on this ORD and CHR?
I mean, I haven't gotten there yet in the iBooks, but I imagine that it probably tells you what it is.
Yeah, apparently the chapter does mention CHR and ORD. Good for them. I was literally reaching into decades old memories. Okay, decades of Python. Haven't done that particular thing since, I don't know, before any of you were born. It's true. Okay, so everyone satisfied with this answer? Okay, how about the next question? The computer science faculty meeting was the other day, and one of my colleagues mentioned that he asked the question in class, and he just got so exasperated that nobody responded with an answer that he waited 10 minutes in silence. He ate his lunch until somebody answered. So I don't know if I'm going to go quite that far, but I'm willing to wait a little while for you to come up with a question. Go ahead.
So I'm working on something else with a group of friends, and I was just quickly wondering, since like we have to why not? How do I get like data and stuff automatically?
Okay, what do you mean by automatically, and what do you mean by data?
It's a CSV file, and I would have to download it from the internet, like at least every day for it to work properly.
Uh-huh.
But how do I have like the computer go and get it on its own every day?
Would it amaze you to learn that you could do that directly inside Python? So it could go get the data file every time you run the program.
That'd be pretty cool.
Yeah. Now, is that going to be covered today? No.
Okay.
But we will cover it.
Oh,
and
okay.
In fact, if you could email me the URL, so I suppose it has a URL, right?
Yeah, I'm just doing like Yahoo Finance, and then.
Oh, isn't that cool? That's actually one of the projects in this course.
Oh, really?
Goes out to Yahoo Finance and pulls down stock data.
Yeah, I did this one thing. So I take like the CSV. I keep thinking of CVS, but it's not. I take that and I take the adjusted closing price over a year or 5 years or however long I want the data to be. And then what I did is I decided to make an average for 30 days, every 30 days, and then an average for 100 days. So you know, and then I graphed all three of those things. So the price, the average over 30, and the average over 100. And then I did something where it shows me where the 30-day and 100-day average cross, in which direction the 30 days is moving. So cool. I would know when to buy or sell.
Cool.
Yeah.
That is terrific. I'm trying to run the project that deals with stocks, and it just crashed on me for some reason. Maybe let's see, it used to run here. Yep, Yahoo Finance API. Maybe I haven't installed the things that I need. But yeah, you can see it on screen. This is exactly one of the projects.
That's pretty cool.
And let me go. So you would import Y Finance as something, and then go get a ticker. And then you got to do a little bit of magic. So yeah, there's a lot of data there, and then you have to pull out the data that you want. Okay, so if you're willing, given that I just ran it and it didn't work, let me see why. Chart. So I think I have all those. And it's supposed to search for Python, for Microsoft, Python 3. And I'll just try it one more time. And if it doesn't work, we'll move on. Nope, it's not working. That is cool. It's a good thing I checked. So I'm not going to send you this source code because it doesn't work. But it used to work. Okay. So if you wanted to get started on this right away, you could, let's go back to the browser, and you could search for Python Yahoo Finance API. And there it is. And here's how you would install it on your own machine. Notice I was running on my machine, not on the REPL. So how could we get it into REPL? And then I have to stop down this digression. How do we get it into REPL? Let's see. Here and Yahoo. What is this? Quick module. This might not be the same one, but REPL does support scraping stock data from Even REPL supports scraping stock data.
Cool.
Okay, what's this one? Oh, there's weather. Okay. Here's another one, Yahoo Finance. Okay, but hey, didn't I tell you that Python has a module for everything?
Yes.
Okay, there you go. All right, so that's all I can answer for you right now. Okay. But I did give you some hints as to where you could do research. Okay, what's the next question?
For this next project, would it be like possible to use like the filter function within Python or like map to handle all of the looping and entering it into a dictionary, or just have to write it all
out? Yeah, I wasn't able to see who the speaker was. Was that Eric?
Eric, yeah.
Okay. There was no little yellow box. Now there is, of course. So let's see. Project 3 that's the one you're working on now, correct?
Yes.
And that's the one with counting the words in Frankenstein?
Yeah.
Okay, and your question is the filter function?
Yeah, so because I know that it returns either, I'm pretty sure the filter function returns true or false based on something. So would it be possible to just use the filter function to check if everything's true or false, and then if it is, just add it to the dictionary like counter? Or I don't know if I'm explaining it that well.
So you want to use it to determine whether or not something is in the dictionary?
Yeah. Or in the file, and then if it is like handling I guess the looping aspect of it, and then just automatically giving a value based on like a certain word.
Okay. Well, I'm going to push back in the following way. So this file has, I don't know, 300,000 words in it or something like that. What you're proposing sounds like each time you wanted to look up a word, you'd have to open the file over again, read through the whole thing. Whereas the way that the project is specified, you only read the file once and you build up a database in memory, and then you can answer all the queries from memory. So it's lightning fast.
Okay. I guess I forgot to, I did not word it well, so I'm sorry. But like, since it takes an iterable as a second argument, couldn't you just put like I forget what it's called in Python, but like, couldn't you just do the for loop in the second half of the function argument as the iterable? So like you would just put it after like with open whatever as f, and then like filter dictionary dot append or something, and then as the second argument just put f like for l in f dot read lines or something like that.
How would that keep track of the count then?
I guess that you would just check if the output, if true based on what's in the dictionary, would come back or not.
Well, I'll tell you what. Why? That's certainly not in the purview of today's class.
Okay.
But if you're interested in exploring it further, feel free and welcome to make an appointment with me, and we'll talk about it.
Okay.
Okay? Okay.
Thank you.
You're welcome. Other questions? Okay. Now, Santana, I promised you the ability to use pictures. And I was doing research to make sure that I'm able to do that, and REPL's not supporting it.
Oh, really?
Really? Right. So if you want to work with pictures, for anyone who does want to work with pictures, we're going to have to use Python on your local computer. Excuse me one second. So maybe it's a good idea that we do that anyway, because your whole life is not going to be in REPL. You'll want to be able to do things lightning fast. So by show of hands, and that means you could use the reaction buttons. You don't have to turn on your camera. By show of hands, do thumbs up or some signal that you have a Mac. Okay, so about 5 people. Okay, and of course, everything's different between the Mac and Windows. All right. So I will promise before the end of the semester to figure out some good instructions, concise instructions for how to be able to run Python locally on your own computer. Let's see, now on the Mac, it would be from the terminal, and on Windows, it would be from the command line, which is their equivalent of the terminal. And I can show you how to do it both ways. So Santana, I wanted to get back to you on your request to work with pictures. Okay. Other questions? All right. Okay. So let's take a look at what I want to do today. And here it is. Okay. So just to remind you that if you want to raise your scores on the readings, sometime after the 16th, I'll regrade all the chapters. And if your new grade is higher than your old grade, I'll give you the new grade. Okay. So I want to do review of the width, try and accept, and CSV. And also, I want to show you and have you switch to a slightly different way of writing your programs. So I'm going to do that first by going to REPL. So go there with me, please. Okay, and we'll start here. So far, we have been writing our programs by just writing code. Print, hello. And if I run that, Python main.py, it runs. Okay. And you can keep writing your code this way, but this is not the preferred way of writing your code. Rather, it would be done using functions and with a technique that I'm about to type in. So let's say this is our main function. And now follow me here. So if this is at the top level, so if the code begins right at the beginning of the line, that's what I'm calling the top level. So if dunder name dunder, so dunder is double underscore. I wonder if anybody's ever put in, anybody? That's not a keyword, is it? Yeah, I wish it was. Okay. And if you don't get it, I'm not explaining it. Did anybody get it? Okay, good. All right, so dunder, name dunder equals a string, dunder, main, dunder, 2 characters, yep, 2 underscores. Okay, now I'm going to put some code again at the top level. This is top level. Hello from main. Okay, so I'm going to run this, and they both print. So that tells us that this built-in Python variable, dunder name dunder, is finding the value of the string dunder main. Okay. Now, the reason why this is important is if you structure your programs this way, it will enable you to split complicated programs into multiple files, multiple Python files. So go ahead and let's see, I'm going to delete this. Go ahead and create a new file, and we'll call it, oh, I don't know, getData.py. And in here, we'll put in a function. So def read CSV, and we'll give it an argument of the file name. And all it's going to do right now is just print the name of the file that it got. Hello from read CSV. File name is, okay, I'll leave that there. So I've got 2 files. Main.py is going to make use of getData.py. Okay. Let's figure out how to do that. Let's go back to main.py. And we know how to import, right? So from get data, import, what do I call it? Read CSV. Okay, and now I can make use of read CSV. Let's see if this works. Oh, look at that. Okay. Now, where this comes into play is if you had multiple files in your program, the only one that this is true for is the one that matches the name of the file that you ran with Python. So let me demonstrate that. Okay, so I'll just say print. This is the file you, quote, ran. And let's go to get data. If dunder name not, how do you do not equal? We'll figure that out in a minute. Not, okay, we'll do it this way. Name equals main. So get data is main. else get data is not main. Okay, let's try that. Now I'm going to run main again. And did we get both? Hello from main, hello from read CSV. I was expecting to see get data is not main, but we're not seeing it. Okay. Forgive me for that.
Were you expecting to see get data is main or is not main?
I was expecting to see, oh, it's there. I didn't even see it. Yeah, sorry. I completely overlooked that that one. So notice that it happened first. But it recognized it wasn't the file that I ran from Python. Notice it happened first, and that's because code at the top level is executed as it is found. So from getData, which is getData.py, import read CSV. So on line 1 of main, it read in getData.py, and it found at the top level code and executed it immediately. That's why it's printing first. And I could not see that. Thank you for pointing that out. Otherwise, I was saying, what the hell is going on here? Okay, do I have any questions for writing your programs in this way?
I'm still a bit confused on how the read CSV part functions with the file part.
Here, well, I'm sorry, what is your, could you articulate your question differently?
Sorry, like I'm confused on how read CSV works with it. It's like I'm getting stuck on it right now. Like,
Well,
it works.
It doesn't actually read a CSV file.
Oh, it's just the name.
It's just the name.
Okay, I got confused. Thank you.
Yeah, sorry. So if you make use of this type of syntax, then you will be able to reuse portions of your code over and over and over again. So for example, Michael might have this reporting program that gets stock data, but he might also have a program that charts stock data. And that way, using this approach, he would be able to reuse the same program code for getting the stock data, right? So he wouldn't have to write that part twice. All right, any questions? Okay, so let's take a look at review of exceptions. And how about something simple? Oh, we got to follow the new rules that the professor said. So def main, okay. And what does pass do here? Anybody?
It just means we'll get to it later, right?
Exactly. So later is now. Okay. And what shall we do? How about just a number is input, enter a number. And this is all it's going to do, print a number. That's all I wanted to do. Let me run the program, enter a number, 34. I'm done. But this, we're talking about exceptions, and exceptions are often associated with errors. So there's an error that's lurking. Let's run it again and enter something that's not a number. Yep. Oh, my mistake. I forgot something. Int. So I want to turn it into a number. Sorry. So if I enter a number, it still works fine. Now if I enter not a number, I get a crash. So what we learned on Tuesday is we could use exceptions to catch errors and deal with them. So we used file not found error, but there are a lot of other errors. So how about catching value error? So how about try? That's what you want to try. And except, sorry, no colon there, except value error. And print, you did not enter a number. Okay, let's try that. So here's a number. I'm surprised about the spacing there. Where's, oh, somehow I put in a tab. Let me get rid of the tab. There, okay. Run that again. Enter a number, 5. That works. Enter a number, and I put in garbage, but that's not a number. And it says, hey, you know, you didn't enter a number. So the try introduces a block of code, and except will catch errors of a specific type. The code that I have here will catch value errors. But if I get another type of error, it won't catch that. So for instance, F equals open of a bad file. I told you last time, put it inside a try. Well, here it is. It's inside a try, but I still crashed. So the only error I've handled so far is the not a number. So you can put, if you need to handle multiple errors, you can put in multiple excepts. Okay. So for as many errors as you want to guard against, you can put in exceptions, exception handlers. The file did not open instead of a crash. There's more to learn about exceptions. Today, the new knowledge is that you can catch more than one exception, but the main purpose was to review using exceptions. So does anybody have any questions on exceptions to the degree to which we've covered them so far?
With the exceptions, is there an order that they need to be in, or is it just whatever you think of?
Whatever you think of.
Okay.
Right. So the order in which you specify exceptions is irrelevant. Okay. So things that we will learn about exceptions in the future are how to create our own exceptions and use our own exceptions, and also how to get more information about the error from an exception. We have not covered those two items yet. Okay. How about some review with the with statement? Okay, so I'm going to combine ideas here. I'm going to put the processing. So this is the main program. I will put the top level code, which I'm reusing the words, but I feel bad about that. How about I'll put the main code here and use other files for support functions. Okay? So I'll say from get data, import read CSV. And that's where I'm going to read the CSV files from. And let's do this because we're on to something else. I'll get rid of that. And I can put this here. This is going to be good. But I'm just going to add a little bit of words. In main, the file did not open. Okay. Do you still have studata.csv, everybody? Good. Okay. That's what we have so far. That's in main. Now let's go work on getData.py. It's a separate file. And what's nice about this approach is everything having to do with one idea, you put in one file. So here the idea is getting the data. I'll put all of my code relating to getting the data in the same file, so that if in the future I need to go find the code that involves something about reading the data, I know exactly where to look. And also, when I open up main.py, I'm not blown away by how long it is, because parts of this program are implemented in other files. Let's go to get data. And this is going to be review of the width. So let's put that in. Let's do that. Width, open of file name. That's where I'm getting the file name from the argument. As file in, or in file. And print file is open. Print file is closed. So that's the cool thing about the with statement, is with this open file, call it in file, there's a block of statements where in file is recognized as an open file. But as soon as that block of statements is over, the file is automatically closed. Okay, let's see if this works. Cool. So the file name came to us from main, and the file was opened using the with open. Then it was automatically closed. And then we went back to main. Oops, here. But now we're about to learn something. Well, first of all, does anybody have any questions about this? So let's go back here or here. Do you have any questions? That was a raging puppy. Hi, Lily. Hi, Fredo. Go away. Okay. Anybody have any questions? Okay, what I've been telling you before, that what happens when the file that you want to open doesn't open? So look, there's no try here. What's going to happen if I give it a bad file name? So instead of StuData, I'll give it that file, whatever the heck that is. Let me run it. Oh my goodness, what's going to happen? There's something interesting about exceptions. The exception still worked, even though the try is in over here and the error was generated over here. So let me explain that. Okie dokie. Let me explain that. Okay. So suppose you have a function that is executing code, and then it calls a function. So that goes here, and it executes code, and then it calls a function, and it executes for code, and then it calls a function, it executes code, and then here is an error that causes an exception. So here's what's going to happen. You're way down here, and the error happens, and Python says, in this function, is the error handled? No? Okay. Then let me look at this function. Is the error handled? No? Okay. Let me look at this function. It goes back up the chain, percolates upward. Is it handled here? No? Okay. Is it handled here at the topmost level? No? Crash. However, if you do handle the error, let's say it's here. Here is the except for file not found error. It would percolate from here to here, and then from here to here. And the Python finds the exception handler here, then that's where it handles the error and continues on. So you see how the exception handling causes it to percolate upward, looking for an exception handler. And if it finds one, it's happy. If it can't find one, it crashes. Okay, any questions about that? So exceptions percolate up. And one of two things happens when an exception occurs. One is it can't find a handler, your program crashes. Or two is it finds a handler and your code gracefully handles the error. Come on, there's got to be a question now, because this is a confusing concept. Oh, Chad, you're on the edge of your seat. You're about to ask a question.
I didn't think
Anybody?
of any.
Okay. All right. So this was review of the with statement. And come on, Lily, get out. Out, good girl. All right. So this was review of the with statement, and also some new knowledge, more knowledge about exceptions. So now I'd like to turn to working again with the CSV. You have to import CSV, and then we can make use of it. We will wrap the open file inside a CSV reader. Okay? And then we can read the file, interpreting it as a CSV file. So how about this? Let's say we just want to return all of the lines in the file broken up by their columns. So the all lines is an empty list. Now let's read every line from the CSV. So for the row in R, how do you append new information to a list? Does anybody remember? Is that one of my famous white horse questions?
Dot append, right?
There you go. Okay, you know, it's hard to come up with phrasing so that it's always one of these white horses. So, okay, so all lines dot append the line that I just read. Okay, I'll leave that there for a second. Now that I've collected all the lines in the list called all lines, how do I give it back to main? Right, remember, if we look at main.py, I have a function called main, and I'm calling read CSV. Let me fix the file name. Read CSV, and somehow I'm getting data back from read CSV. So there's a way that I have to return the data, and that would be another white horse, return all lines. Okay. Any questions about that? Okay, so all lines, which is a variable that is local to read CSV, will be returned, and its value is going to be inside data. Let's see. All right, let's try that. There are 3,000 lines in that file. I want to show one more point that's buried in here. So you don't have to do this at home, but I'm going to just create an empty file. And I'll just do that real fast. Okay, and that just created an empty file. You don't have to do this at home. And instead of new data, I'll ask you to open empty. All right. Empty.csv. Oh, I spelled it wrong, but I handled the error, didn't I? I didn't crash. Now, I leave it to you to decide whether or not I did that on purpose, but between you and me, that was an accident. But it was nice. Okay, so let's run this again. Well, that's unfortunate. It's an empty file. Oh, there must be one line in it. Yep, okay. I really, really, really wanted it to be empty. So let me go here and empty.csv. Okay, now it's empty. All right, let's try running the program again. There are 0 lines. And that's what we expected, right? The point I want to make is I can use the amount of data returned to signal some other type of error condition. Like over here, I'll say if the length of data is greater than 0, else no data returned. So this might seem obvious, but you're learning techniques to improve the usability and robustness of your code. So here, I'm not only using all lines to return the data, but I'm also using the fact that it's empty as other useful information. So it starts out as empty, and if this loop produces no append, it'll go back to main empty, and we could recognize that and deal with it. Alvin, question? No? All right, I'm batting 0 for anticipating the folks who have a question, who I believe have a question on their lips. Okay, you might be wondering why I'm not wearing my glasses, and it turns out it's because they are coated with dog lick. So that's why it's not on. All right. Okay, so far we've reviewed just how to open a CSV file and how to read its lines. We have not reviewed how to access the data inside the CSV file, row by row, column by column. So I'm going to go ahead and I'm going to edit. Don't do this at home. I'm going to edit one of these lines. So let's say this line, this first line, is missing a field. Okay? So all the other lines have 1, 2, 3, 4, 5, 6, 7, 8, 9 fields. So I'm expecting 9 columns. Let's go to read. Read CSV. And what if I wanted to skip any line that doesn't have the right number of columns? Can you tell me how to do that? Anybody, pretty please?
Would it be pass?
So pass says do nothing. It's just a space filler. So on line 7, we've captured a new row from the file, and row is now a list of the columns. So we are expecting the length of row to be 9. So only in that case will we append, and perhaps we might want to put out an error message, maybe. And the error message might be skipping line, and then we'll just put it in. Okay. Let's run the program. And I guess I have to change the name of the file. Yeah. Okay. So what I've just shown you is an example of vetting the data. If you are using a data file, you should be careful about not making assumptions about its contents, especially if such an assumption would result in a crash. Okay, so the code here, it's not convenient to switch files, I'll tell you that. So here is an example of vetting the data. VETTING, or error checking, or my favorite, sniff testing the data. If the data doesn't smell good, don't use it. Okay? Somebody's got to have a question.
I do.
Good.
I'm confused on what the in file accomplishes.
Okay. So there would be, if you were to not use the with construction, you might say in file equals open file name, right? So in file is just an arbitrary variable name. And I chose it because it's a file that I'm using for input. So Santana, the choice of that variable is up to you.
Okay. I always keep messing up with like the variable ones and the ones that like have specific input ones already, like with define.
Good, good. I understand. Take a look at the coloring. That does offer a clue. So the variables seem to be in, I think that's black. Okay. So the blue is part of the Python language itself. The purple is a function. So notice there's purple, there's purple, there's purple, there's purple. They're all functions. And then the black is something else. The red is what's inside of a string. Ooh, by the way, there's our evidence that we really did screen out the one row that was no good. While I'm thinking of it, I should go fix that again. Was it Sarah with an H or Sarah just Sarah? Who knows? We'll never know. Okay, so we don't have enough time to go into another topic. So once again, I would like to ask you if you have questions. Something that you might ask me is to implement, how would you implement checking student numbers or something? Okay, nobody has a question? I'm so disappointed. Oh, that sounded promising, but no question actually appeared. Okay, with that said, I'll leave you with this. You have a review day coming up, and I remind you that during a review for an exam, I don't say anything except in response to a question that you have. So if this kind of multitude of questions being asked of me is repeated on the review day, it'll be a really short class. And then the day after that is, the class day after that is an exam in class. Now here's the thing, the exam is in class, so it's 100 minutes. The exam itself is designed to take less time. So I'm intending that it doesn't take you 100 minutes, but maybe it will. So in order to provide for extra time, the exam itself will become available at 9 a.m. Okay? So it'll become available in Schoology at 9 a.m. And please, on your honor, don't talk to the morning class. You can start the exam at 9 a.m. and work on it as long as you want. The exam will close at 4 o'clock. And please don't talk to share information with the earlier class, okay? All right, let's go away. Oh, Peter, do you have a question?
Yeah, so are we taking the test in class, or is it, we can just do it at 9 a.m. if we wanted to?
You can do it at 9 a.m. if you want to.
Okay, thank you.
And we can use like Zybooks and all our resources, right?
Yes, you can use all resources except the answers provided by another student.
Oh, sorry, one more question. What is the date of the test again? My bad.
Let's take a peek. Let's go to, what's it called again? Oh yeah, Schoology. And it will be on the 18th is for review, and the exam itself will be the following Tuesday. These times refer to due dates. So for the first class, it's due at 11:30, and for your class, it's due at 4. In both cases, it opens at 9 a.m. Okay, other questions, anything? All right, have a great weekend. Stay warm, don't get sick.
Thank you.
Everyone, everybody.
Thank you. See you next week.
Thank you.
Thank you.